Hello everyone, here are the answers to the 12 homework problems I assigned yesterday. So if you wish, pause the video now and you can just compare your answers to the solutions here, and then you can try correcting any that need it on your own, and then just let the rest of the video play and I show step by step each problem worked out. All right, so for the first 4 problems, all you had to do was state the LCD, so I want to go over these. So for number 1, the first denominator, we factor just into an x minus 1, x plus 1. Now if you notice, the other denominator has an x minus 1. So with the LCD, since they have common factors of x minus 1, we write that once. And then this first denominator also has an x plus 1, much like the in-class example we did yesterday. For number 2, these are all just monomials. So again, we look at the numbers. So 4 goes into 12. So we need to use a 12, and again the c's, the single factors of c, can go into c squared. So that was like our 8 n squared problem from yesterday. So we have 12c squared as the LCD. For number 3, we can't factor either denominator, so this is the case where we just simply multiply them both together. So it's x times the quantity x plus 1. And in number 4, we can factor the first denominator. It actually factors into m minus 4 times m minus 4, or m minus 4, that quantity squared. Now the other denominator has an m minus 4, so m minus 4 goes into m minus 4 squared, so that is our LCD. You could write either m minus 4 squared or just m minus 4 times itself. All right, for number 5, we are subtracting 2 fractions. I want to follow the steps. I want to make 2 blank fractions. The LCD, now these are both monomials, so 3 and 2 can both go into 6, and each denominator has a v, so my LCD is 6v. Now 3v gets multiplied by 2 to get 6v, so I need to multiply 7 by 2, so we're going to get a 14 as our first numerator. 2v gets multiplied by 3, so 8 gets multiplied by 3, and I get a 24. Now we're going to make one big fraction. 14 minus 24 is negative 10, and then we could still put this in lowest terms, divide the 10 and the 6 by 2, or the negative 10 rather, so we actually get a negative 5 over 3v. In number 6, we could actually go ahead and start by putting that 2 over 1, so I'm going to make 2 blank fractions. Nothing to factor here. 1 goes into anything else that would be the other denominator, so my LCD is just going to be a minus 1. No need to write a 1 in front of that or multiply it by 1. So now my first numerator just stays the same, negative 3 minus a, but my second numerator has to get multiplied by the a minus 1. So I'm going to write it this way. So there's our first few steps. Now I'm going to make one big fraction, keep the denominator, and I'm going to distribute this 2 that's over here. It's a positive 2. So we're going to have negative 3 minus a plus 2a minus 2. We're going to combine like terms. 2a minus a is just a. Negative 3 minus 2 is a negative 5, so we get a minus 5 over a minus 1. Number 7, I can go ahead and factor the first denominator. Now usually a common factor is going to show up of r plus 5, so that's a nice clue to help us. So we're going to do r and r, we're going to do 5 and 1, and everything's positive. So as I go to make my 2 blank fractions, my LCD is going to be the quantity of r plus 5 times the quantity of r plus 1. Now the first fraction already had both of those factors in its denominator, so the 2r just stays a 2r. But the second numerator has to get multiplied by the r plus 1, because that's what we multiplied the bottom by. So there's our first couple steps. Now I'm going to make one big fraction, keep the denominator, and I'm going to go straight across here. Oh, that was a minus in between. So we're going to have 2r. Anytime it's a minus, I don't want to do too much at once, so I'm still just going to write it as minus r times the quantity r plus 1. Now we'll go through and distribute a negative r. So we get 2r. That'll give us minus an r squared minus r all over the denominator. All right, combine like terms, I'm going to get a 2r minus r. Since that's going to be positive r, I'm going to write that first. We're going to get r minus r squared all over r plus 5 times r plus 1. Now it's always good to check, see if this could factor r minus r squared, and it can. We can factor an r out, and we'll get a 1 minus r over our denominator. Now, even though it looks it at first, these are not opposites. 1 minus r, the opposite would be r minus 1. These are not opposites. Nothing crosses out, so this is our final answer. All right, looking at number 8, again, I'm going to start by factoring the denominator. Again, over here we have an n minus 5, so chances are that's going to be a factor. So we'll try that. N and n, we'll do 5 and 6 will give us 30. Minus 5 plus 6 works to give us that positive n in the middle. So I'm going to make two blank fractions again. N minus 5, n plus 6 is our LCD. Now the first numerator has to get multiplied by an n plus 6. I'm going to write it that way. 2 times the quantity n plus 6. 5n minus 3 doesn't have to get multiplied by anything. It already had both factors. But I am going to put it in parentheses. So now we're going to make one big fraction. Keep the denominator. Let's distribute the 2 here. So we're going to have 2n plus 12. Now do this carefully. As we subtract, we're going to subtract a 5n, so it's a minus 5n, and then subtract a negative 3, so that kind of saves us a step. So we get a minus 5n plus 3. Combine our like terms, we're going to get a negative 3n plus 15 in the numerator over the quantity n minus 5 times the quantity n plus 6. Trying to simplify as far as we can go. There is a GCF of a negative 3 in the numerator. This would leave us with an n and a minus 5 over our denominator. And now if you notice, the n minus 5s do divide out, and we're left with negative 3 over n plus 6. Okay, looking at number 9's denominators, if you notice, they are opposite. So I'm first going to rewrite this as 3 over x minus 1 plus x over the opposite of x minus 1, because 1 minus x is the opposite. 1 minus x is the opposite of x minus 1. So that's how I rewrote it here. Now I can move the negative, so we're just going to get plus a negative here. So I could write this as 3 over x minus 1 plus a negative. We'll write it this way. X over x minus 1. Plus a negative turns into just a negative. Adding the opposite is the same as subtracting. So again, these two signs turned into this one right here. So now I'm going to make one big fraction. My LCD here, just my common denominator is x minus 1. Up top we get a 3 minus x. And that's all we can do with that. Number 10, both of the denominators are monomials. They have nothing in common, so I simply multiply them together. So my LCD is xy. So this 1 has to get multiplied by a y. We did x times y, so we do 1 times y, which is just y. 2 has to get multiplied by an x, because y got multiplied by x. We have 2x. We make one big fraction. Keep the denominator. Up top, we just have y minus 2x. In this case, there's nothing else we can do. That is our final answer. Now, if you take a look at 11, it does look different than all the others, right? We're not adding or subtracting two fractions. In fact, this is an older type problem. All we have to do, this is just a single fraction. All we have to do is factor and then cross out. We're not going to state restrictions. So in the numerator, there's a GCF of m squared. That's going to leave us with an m minus 3. In our denominator, we have a 3 minus m. And yes, these are opposites, so as we cross them out, we're going to leave a negative 1 times m squared. We just get a negative m squared. Then the last example, number 12. In a first factor, start by factoring the d squared minus 9. That factors into d minus 3, d plus 3. That is our LCD, because d plus 3 is the same as 3 plus d. We're just switching them around. So as I go to write this, my LCD is just going to be d minus 3 times d plus 3. So the first numerator just stays the same, 3d. but the second numerator has to get multiplied by a d minus 3. So we'll have the d, then we'll do d minus 3. Next, we'll make one big fraction. And go straight across the top here. We'll have 3d. We're going to distribute a positive d here. So we'll get plus d squared. Then this will give us a minus 3d. And as we go to combine like terms, the 3d's are going to cancel out. We'll have d squared over d minus 3, d plus 3. All right, so I am assigning another worksheet here. You guys will have 10 problems. This will be as a separate PDF for you guys to access this, but your assignment is to do the adding and subtracting rational expressions worksheet. Call it worksheet 2, and there are 10 problems. So you'll see this posted as a separate PDF in this post today. All right, just let me know if you have any questions, email me, and I could set up individual one-on-one Zoom meetings if necessary. Have a good day, guys.